Now the practical one is that how to calculate the flow through any conduit or any piping network. In our case, it will be circular pipes. Continuity law. What continuity law says? That flow is the product of cross-sectional area and velocity. With the multiplication of these two, with the product of these two, we will get the flow rate. So cross-section area of a circular pipe is pi d square by 4. D is the diameter, but remember, D here is the internal dia of the pipe, not the external dia. Because fluid is flowing in the inner side within the conduit, the dia or the thickness can be high or small, but it doesn't depend on the outside diameter of the pipe, or it doesn't depend on the thickness of the pipe. The flow, the cross-section area will be inner dia, and inner dia is outer dia minus 2 times of the wall thickness of the pipe. The wall thickness of the pipe will keep on varying depending upon the class of pipe. If you are installing class B, it might have a thickness of around 3.4 millimeter. If you are going for class C, it will be around 4.9 millimeter, and D and E. So these, what I'm talking about, these are the standard for British pipe, which number is, I suppose, BS3505. So BS3505 is a pipe standard for pressurized pipes. And what about the Pakistani standard for pressurized pipes? So let me be very frank, it's the exact copy of British standard, and it's called PS5051 if I'm not mistaken, but it is, I think, something like 5051. In that standard, whatever the product, you being an engineer, whatever the product you buy from the market, it must meet to the standard of BS3505 if they are being manufactured with that standard. Or even in Pakistan, to very low extent, we use DIN standard, in PVC I'm talking about, or ISO standard. But major of the, I would say that 99.9% of the market is availability is BS3505. Okay, and what about, just see, in high efficiency irrigation system, we try to limit our velocity not to exceed 1.5 meter per second. And the reason is that we want to avoid water hammering. I hope you all know what is water hammering, especially those are final year or second last semester. Water hammering, we just want to avoid water hammering, so we limit our velocity to 1.5 meter per second in irrigation system, and even in the water supply systems. Okay, and this is, let's talk about that how much water carrying capacity of a 3-inch pipe will be at the velocity of 2 meter per second, for example. So this is what you, hopefully you can see it, that NPS 3 class B 3505. This is very important. NPS is nominal pipe size. Nominal pipe size means that it's the, for example, nominal pipe size is 3 inches. But if you analyze the 3-inch pipe, it will have a outer dia of around 3.5 inches. So why we call it 3 inches? Because it's a nominal, ghalatul aam, urf aam. What we call urf aam or ghalatul aam, it's called 3 inches, but by the way, it's not 3 inches. As per the BS standard, it's around 88 millimeter. So 88 divided by 25.4 will give you around 3.5 inches. But actually the pipe is 3.5 inches, but we call it 3 inch. Actually the pipe is around 2.25 inches, but we call it 2 inches. That's why we use the term nominal size. Nominal, ghalatul aam ya urf aam, right? And the thickness of that pipe is around 3.5 millimeter. So 88 minus 3.5 will give you around 82 or 81.9 millimeter. So the internal dia is 81.9 millimeter, and the velocity that we maintain is 2 meter per second. So installing or putting all these values in the equation here, we will give 37,878 liter per hour. You may have some conversion factor with it, but overall, so the velocity, the maximum carrying capacity of 3-inch pipe with 2 meter per second velocity will be around 37,800 liter per hour. Now see, if we reduce the velocity to 1.5 meter per second, so what will the carrying capacity will be? It will be around 28,000 liter per hour. So just a little decrease of around 0.5 meter per second, the carrying capacity of any particular pipe of 3-inch sizes will reduce by around 10,000 liter per hour. So these two are very important. Now, and similarly, if you for example, this is 88 is outer dia and you go for class C pipe, then the inner dia will become around 77 or 78 millimeter. So the carrying capacity, the water carrying capacity will further reduce.